All right, just like your unit test, here we have a couple of multiple choice problems, and we spent really yesterday on all of problems just like this. You have a whole packet of them, but these are great to look at because they're very similar to what you're going to see on the OST. We've seen a lot of problems like this. So here we're using the scatter plot of monitor size and price for questions 4 through 6. We have a company researching monitors to replace them for their information technology team. What is the best interpretation of the slope of this trend line? So the first thing I'm going to do before I even look at the interpretations is find slope. So I'm thinking rise over run here because I'm doing it from a graph. If you start to look at the numbers here, there's like 1 and 34. And then when I look over at my graph, 34 is nowhere on there. So I know I'm going to have to do some work here. The first thing to do, if you can, is draw a best fit line. So I'm going to try to draw as nice of a best fit line as I can. If you can grab a straight edge, that's really helpful. Use, the side of your notebook or your calculator or whatever you have available for that straight edge. So here's what I'm seeing on this line. If I kind of start here and go to the next nice spot, again, this is going to be an estimate because we're not given the actual data points. So here it looks like I'm going up 1 unit, but 1 unit is from $200 to $400. So there, I'm going up $200. And then over from 6 to 12. So from 6 to 12, that's 6 inches. So if we do 200 divided by 6 over in decimals, you can clear out. I said always start with a clean screen. 200 divided by 6, we get 33.33. So now that $34 number kind of makes sense. So here we're going up $200 and every time per 6 inches. And we said that reduces to 33.33. I'll write that down here. 33.33 per 1 inch of monitor. So let's read through and see which one's best. For each additional 1 inch of monitor, the predicted price decreases by $34. Our price is not going down, our price is going up. For each additional 1 inch of monitor, the predicted price increases by $34. I like that one, but I'm going to read the last one. For each additional 34 inches of monitor, the predicted price increases by $1. That one, no thank you. So B was our answer there. What's the best description of the relationship between the monitor size and price? So here, as price goes up, monitor size goes up. So that is a positive association. If we were going to talk about an R value for this, I would say like 0.9. So that would be positive and definitely strong. We're really close to that line here. Which statement is most accurate interpretation of the association? More expensive monitors tend to be smaller. I don't think so. Larger monitors tend to be more expensive. I like that. Size causes monitors to cost more. We never, if we're given a scatter plot and the OST tries to trick you like this, which is why we talk about it every chance we get, we never want to say cause if we're looking at a scatter plot. What we want to say is tend to. What we want to say is there's a relationship or an association. We never want to say the word cause. We can say correlation, but we cannot say cause here. All right, so that is the scatter plot for monitors. Now we're going to do scatter plot for dinosaur sizes. The following scatter plot shows weights and lengths of dinosaurs. Which statement accurately describes the information? So A is a positive correlation. The weight of a dinosaur tends to increase according to its length. Well, here's our weight going up and our length going up. And it looks like if I was going to draw a best fit line there, it would be kind of like that. So I like that one. But we should always read. It's a great test taking technique to look at our options, and then if we don't find a good one, like, kind of circle the best and make sure the other ones don't fit. The information shows negative correlation. Negative correlation would be a downhill trend. And so that is not it. The information shows no correlation. Remember, no correlation would look like snow. And since we could draw an uphill line here, we definitely don't want to say that this is no correlation. All right, last one. The police department tracks the number of ticket writers and the number of tickets issued for the past 8 weeks. The scatter plot shows the results. Okay, more ticket writers resulted in fewer tickets issued. So here are number of ticket writers going up and our number of tickets written going up. So this is going to be positive again, like our other two. That is not a good best fit line. We want to kind of go through our data there. So not A. There were 50 tickets issued every week. Okay, so here are the number of ticket writers and the number of tickets issued. We don't have any information about what happens every week, so we cannot say that. When there are 10 ticket writers, there tends to be 800 tickets issued. So the best fit line is helpful here because that's what you're always basing your tends to statements on. If we look at 10 ticket writers, I would say our best fit line was, and we have a data point right there too, would be around 600. 800 is all the way up here. So I would say no for that one. More ticket writers tends to result in more tickets issued. I like that tends to result. That's our correlation, that's our scatter plot terms. If they said cause, it would be a big no there. All right, so that was your review. Please let us know if you have follow-up questions. It would be a great thing for you to go back and work on any practice on Canvas or any practice on paper, especially with these multiple choice problems. You had a big packet of those. Those are great practice for this unit.